called problem 1428, leftmost column with at least a 1. I don't want to read the descriptions because it's so long. Let me just describe what we are giving. So we are giving a interface which is a class, so it's going to be boundary matrix, and it has two methods. So the first method is get. So the input is if we are giving a row and column position, definitely we can get the number. And another method is dimension. If we directly call the dimension, we can get the row and column. Yeah, so this is what we are giving. And we are also told that inside the matrix, it's going to be 0 and 1. And they are sorted by row. And in each row, the matrix is sorted in non-decreasing order. So this means for each row, it is sorted in increasing order: 0, 0, 1, 1, increasing, 0, 1, increasing, 0, 0, increasing. Yeah, it is a non-decreasing order. This means we can use a boundary search. And we are also told that we cannot use more than 1000 calls. So definitely this means we have to use a boundary search. Otherwise, it's going to be more than 1000 calls because the row and column is 100. So 100 times 100, it is 10,000. Definitely, it's more than 1000. Yeah. If we already know such kind of information, basically we should know how to solve the problem. So let me just check the row and column. So for this binary matrix is just a class. It is passed into the our class in our solution class. So let me just use capital B as this class. It's gonna call the binary matrix, right? So currently, as I were to calculate the row and column, it's gonna be b dot dimensions. Yeah. Now I have the row and column. So what I'm gonna do? I'm gonna write a boundary search. So I'm gonna call it find index. Yeah, find the leftmost index 1. So this means I want to find the number 1, and what is the index? It is 0 for the example 1 from here. Yeah. So inside I need to check all the rows. So I will give a random row. So this is any row for this find index. Now let me just write the function. So for me, I would write it like this. So the left and the right pointer is going to be starting from 0, and the right pointer is going to be say minus 1, and the result I'm going to set it as infinity. This means if I didn't find it, I'm going to return infinity. Yeah. So now let me just finish the template of boundary search. So while L less than equal to R, I'm going to find the mid position, mid index, it's going to be divided by 2. Yeah. Now I'm going to call the function. So b dot get with this row and column. So row is my row passed inside the method find index, and the column gonna be m. Yeah. So this is what I calculated. Yeah. So if this equal to 1, so definitely I need to shift to the right border, gonna be m minus 1. Else I'm gonna update the left border, it's gonna be m plus 1. Yeah. But before that, if it is equal to 1, I'm gonna record the result, so the result gonna equal to m. Yeah. So finally, I'm gonna return this m. So this means for any row, I'm gonna find the most left index, which has a value of 1. Yeah. Now what I'm gonna do? I just check the function. So for r in range, capital R, because I want to check all the rows, and I'm gonna set a result. So for the result, I'm gonna set it as infinity because I want to check the minimum value. So it's gonna be the result with b dot not b dot, it is the find index. I'm gonna call the find index and with this r. Yeah. And finally, I'm gonna return the result. If the result not equal to infinity, yeah, this means I've already found it. But what if it's equal to infinity? It means I didn't find it. So I'm gonna return -1 according to the description. So if we didn't find it, we're gonna return a -1. Yeah. Now let me just run it to have a check. It didn't work. Let me check. So the first example, okay, second okay, but for the third example, my output is 1. So definitely it's gonna be -1. Let me check. And for this example, yeah, so the output is gonna be 1, but my output is 0. So this means definitely there's something wrong with my boundary search function. Yeah. This is a row, left and right, 0, c minus 1, infinity is b dot get row and column equal to 1. So result gonna equal to m and r gonna because here I need to return the result instead of m. So this is a typo. Now let me just run it. Now as you can see, it works. Now let me submit it to tag. Yeah, as you can see, it passed for all testing cases. And the time complexity, if we are going to analyze, no, definitely it is not 100 times 100. Definitely, the code is going to be less than 1000. It is 100 times log 100. Yeah, so log 100 is like 8, 2 to the power of 8, or 2 to the power of 9. Definitely, yeah. Let me just calculate it. Maybe it is 100. So how many calls? Total calls? Log 100. So what is log 100? Is 2 to the power of it is less than 2 to the power of 9. So it means basically it's gonna have at most 900 calls. It's gonna less than 1000. Yeah. Now let's analyze the algorithm from here. So for this one, this is like log 100, and from here this is 100. So basically the time complexity gonna be n log n. N is 100. Thank you for watching. See you next time.